Recently, I attended a 2-day Math and Focus workshop. Dr. Yeep Bonhar was the keynote speaker each day, and there were several presenters adding to the breakout sessions, elaborating on the K-8 components of the Math and Focus approach. The purpose of this video is to share with you some of the key components to the discussions, as well as my individual takeaway from the event. In order to see things abstractly, we need to create that visualization by modeling it concretely and pictorially in order to represent it abstractly. The question that we ask is, how can we solve it, versus the procedural methods of telling children, this is how you solve it. Different types of questions are going to elicit different results. Oftentimes we as educators ask our students, what is the answer? However, a different set of questions is going to drive a different type of learning. Asking, how can we solve this problem, will elicit one solution. To say, how else can we solve this problem, can elaborate on the methods of the solution and give students further tools for future problem solving. If we're looking to encourage multiple solutions to these problems, not only as a whole class, but as individual students searching for multiple solutions to their individual problems, asking different questions going to foster that. Some of those examples are, would you like to add on? Do you agree or disagree? Or how else can we solve this? And to transition from one individual math learner to another, whether it be a teacher to a student, student to student, or from student back to teacher, these questions are quite effective in encouraging that discussion's progress. In addition to visualizing through the concrete, pictorial, and abstract approach, the anchored tasks are problems that have 5 problems in one instead of 5 different isolated tasks. In this case, oftentimes, less is more. Specifically, referring to the number of problems that we ask children to solve. Bonhar repeatedly encourages educators to establish the fact that it's okay to be wrong. In order for students to genuinely feel that way, we as educators need to create a safe environment. In fact, it's better for the students to be wrong before they're right. The purpose of those anchored tasks is to create that opportunity for students to be wrong before they're right. In working through that rigorous task, they develop the skill of being able to persevere. Being wrong before you're right allows you to better explain your understanding afterwards, and it eliminates that set of possibilities that won't solve the problem. We must allow our mistakes to be seen in order to help support the solution. In the discussions during the breakout sessions, 2 ways allow us to create that be wrong before you're right scenario in a safe environment. Skip counting activity, where you're varying by what you're counting, and most importantly, varying from the starting point. For instance, instead of saying we're going to skip count around the room in round robin fashion by 7s starting at 0, you would say we're going to skip count by 7 starting at 5. The other method I'll elaborate on is for elementary students during math class to write in pen. I had always thought of asking students to write in pen in math for a couple of my own reasons. One of our colleagues during the breakout session shared with me individually the fact that students at Episcopal Academy write in pen in math. And it really got a great discussion going, and what was most important to me in personal takeaway is the fact that later that afternoon, Bonhar offered that same strategy to have students write in pen in math. And knowing that our questions would be instantly why, he offered the responses saying that students can't erase their mistakes. We want the students to be wrong before they're right for those previously mentioned reasons. So, the students will erase their mistakes, but in pen, they can't be erased. Those mistakes display their thinking and drive new learning. It will also give the students access to their mistakes later. Bonhar repeatedly reinforced the concept that remembering is not the same as memorizing. We're looking to develop learning theories through the use of problem solving versus giving students skills in isolated methods to memorize how to do it and to generate a solution. We are looking for solutions, but more importantly, we're looking for the how did you get to that solution versus yes, it's right, move on to the next one. Teachers who foster the practices suggested in the Math in Focus approach will be able to ensure that every child has a mathematical voice. Those educators will know when to slow down and know to ask the right questions. Most experienced educators in teaching math will know when to slow down. However, asking the right questions. What are the right questions to ask? I think the first best one to use is why, following a student's solution. The answer is 23. Well, tell me why. Another way to ask a good question to foster discussion is to say, how else can we solve this? Several quotes reinforce the need for slowing down. President Lincoln said, "I am slow to learn and slow to forget which I have learned." Bonhart repeatedly suggested to stay calm, stay cool, read, and do. One of the quotes that I use across the academics as well as behaviorally in the classroom is slow is smooth, smooth is fast. If we take our time and do it with minimal mistakes, then the smoothness turns into speed. So by going slow, we end up finishing faster. One of our colleagues in attendance asked about fact fluency. How is it and how often would that be reinforced in the classroom? And Bonhart responded by saying, teaching higher order thinking skills and the visualization concept are the responsibility of the school. Reinforcing fact fluency progress is a responsibility at home. What we must do is teach the parents the methods that we've taught the students or allowed them to discover such that they can implement those during the practice of that fact fluency at home. Many of us have used the concept of making a 10 in our instruction for problem solving on those basic algorithms. Through the concrete, pictorial, abstract method, this is the first time that I've seen it done consistently from that progression, concrete to pictorial, abstract. With their 10 grids, the students will be able to physically have 8 on one 10 grid, 6 on another. They can physically move 2 of those blocks to build that 10 and then represent 4 remaining. 10 and 4 give us 14, just as 8 plus 6 gives us 14. Here we have 8 blue X's representing the add-end 8 and 6 green X's representing the add-end 6. What we're able to do is make a 10 by grouping 10 of those and having 4 remaining. 10 and 4 make 14, just as 8 plus 6 makes 14. Here we have another pictorial method of reinforcing fact fluency. If the students are given the problem 8 plus 6, In their mind's eye, they can take 2 from the 6, adding it to the 8, and they can visualize 10 plus 4, giving us 14. If we take our time in our math instruction and use the concrete, pictorial, abstract approach, when the children are working on their fact fluency, represented by the abstract problems, both horizontally and vertically, the 8 plus 6 can be visualized in making a 10. 2 from the 6, adding to the 8, make 10, with 4 remaining, and 14 becomes the sum. If we spend the proper amount of time and quality of time in the concrete and the pictorial methods, the abstract will develop. So the slow is smooth, smooth is fast approach. Slow down the learning so they slow down the forgetting. In the concrete method of subtracting 8 from 14, we can build 14 on the 10 grids. By removing, systematically, what creates a 10 is the first step to the problem. So if we remove 4, we get to the 10. We know that if we remove 4 and we want to fully remove 8, we have to remove 4 more. What remains are the 6 that give us that difference. One of the pictorial methods for finding the difference, 14 minus 8, we have 14. Let's make it 10. We have 10 and 4 still make 14. How can we then come up with 8? 4 and 4 is 8, and the 6 and 4 make the 10. What we're now able to do is take away 4, take away 4. We've now subtracted 8, leaving us with the difference of 6. Given the addition problem, 13 plus 8, we're going to make a 10. What plus 13 gives us a multiple of 10? 13 plus 7 is 20. But we're actually adding 8. So it will be 13 plus 7 plus 1. We know that 13 plus 7 gives us 20, plus the additional 1 gives us 21. When moving on to multiplication and division basic fact fluency, it's suggested to use what the children know to help them find out what they don't. If the students are fluent in their addition and subtraction basic facts, then we can use that knowledge to have them build their multiplication facts. Remembering is not the same as memorizing. What we want to do is use what the students know to help them find out what they don't. The basic facts of the 2s, 5s, and 10s often come more easily than the others. So by adding a row, doubling it, removing a row, or applying the associative property will allow the children step by step to get to that answer. Hopefully the next few slides and elaboration will give more clarity on this concept. The 2s, the 5s, and the 10s oftentimes are easier for students to master because doubling a number is something they're accustomed to doing. We have 5 fingers on one hand and we have 2 hands, so the 5s and the 10s become easy, usually. How can we use our knowledge of the 2s to help us learn the 3s? Well, we simply add a row. Knowing our 2s and doubling it allows us to learn the 4s. Adding a row to the 5 times tables that we know enables the students to master the 6s. Students can use their knowledge of the 2s and the 5s to develop their mastery of the 7s. By knowing their 10 times tables and their 2 times tables, they can subtract the value of that 2 multiple from the value of the 10 multiple. And finally, removing a row from the 10 times tables that they already know gives the product for the 9 times tables. When asking a student what is the product of 6 times 7 and they respond correctly with 42, the follow-up question is why. A typical response might be, well, I know that 6 times 5 is 30. The 5 times tables are more easily mastered. I also know that 6 times 2 is 12. 30 plus 12 gives me 42. Another method a student might suggest, having mastered their 3 times tables, would be that I know 3 times 7 equals 21, and I can double 21 quite easily. 3 times 7 again is 21, and I know 21 plus 21 gives me 42. So when a student responds correctly, 6 times 7 equals 42, that's step 1. The more important step is for them to respond with their answer to the question, why is 6 times 7 42? If we as educators are eager to use our valuable instructional time to fostering that learning environment and encouraging multiple solutions for problems, we don't want to fill our time with fact, recall, practice. In order to properly encourage that to be reinforced at home, we need to teach the parents the methods that we're using. Add a row, double it, remove a row, associative property. In order to do that, the suggestions that were offered were to have a parent math night, much like we've done in the past with new math programs, or a sample lesson and problem, and illustrating the basic facts methods at back to school night. During the 2-day workshop, the questions of why and using the conjunction because were heavily reinforced. As I was reflecting, I was thinking during those mad minute or time test, fact type assessment is to give fewer but require the answer to the why in their statement. For instance, if we ask the children to tell us the sum 6 plus 7, they'll give the answer, but we'll encourage them to complete their response with the because. A typical response might be, I know that 6 is 5 plus 1. I know that 7 is 5 plus 2. Here, the students can make a 10, and what remains can be added to give the 13 sum. Another interesting concept that was repeated is when students are given larger addition problems and subtraction problems, we need to group before they can regroup. For instance, if the problem 369 plus 257 is given, the students need to group those before they can regroup. 9 plus 7 give us 16 ones. 6 tens and 5 tens give us 11 tens. 3 hundreds plus 2 hundreds give us 5 hundreds. Next, what the students can do is say 16 ones are going to give me 6 ones and an extra 10. Adding to that 11 now give us 12 tens, and still 5 hundreds. We'll again need to regroup those 12 tens. 2 tens, our 6 ones remain, and we group 10 tens into the 100. That allows us to get a sum of 626. So grouping is necessary before we can regroup. Toward the end of the workshop, my question became, how does theory become practice? What will this look like in the classroom structure that we already have established? And Bonhart described an hour-long lesson might consist of a whole group problem, one problem, and the slow down process might cause it to take 15 minutes. Then, in the next 15 minutes, the students will be given 2 guided practice problems. And the 30 minutes that remain for independent practice, 3 to 5 problems will be asked for the students to complete independently. The question we always have is, what happens when the student finishes all 5 problems and time remains? In my mind, some specific approaches I've used in my own classroom are to give a fact sheet with maybe 10 basic fact problems on there requiring the because or the why answers, as well as the games 24, set, and some of the everyday math games that we already have established that are excellent for problem solving, interaction, and fact fluency. If the goal is to ensure that every child has a mathematical voice, I feel confident that the Math in Focus approach with Singapore Math can empower the teachers with the confidence and the strategies to ask the right questions in order to slow down the process to maximize the effectiveness and the diversity of the learning. If we're looking to encourage rigor and perseverance, then I fully believe that the Math in Focus Singapore Math approach, as we develop comfort with it, will give us exactly that. The initial purpose of this video was for me to document the things that I felt were noteworthy during the workshop and elaborate my own notes for them. Hopefully this has been at least somewhat helpful to you, and if not, it will at least give us guidance on where to begin with discussion through our in-service and staff development.